Hello, my name's Brennan, and I worked on this project with Jared, Nick, and Jared, and we decided to do our project over CO2 emissions. And for data collection with this project, we collected the average monthly emissions of CO2 in parts per million for the units, and it was for each year from 1958 to 2020. Our main purpose with this was to get an idea of the amount of CO2 emissions that have happened since the data started being collected back in 1958 to present day, and this would give us a good overall view of what has been put into the atmosphere. And so with this, we are going to be using step sizes of 12 since each collected data point represents a monthly average for that year. And so with the step size of 12, we'd then be able to have a rough estimate of a yearly average. And the methods we're planning to use are going to be lower and upper bounds, trapezoid method, and Simpson's method. What a visualization of our data points looks like is here. As you can see, it makes sense that our CO2 emissions have gone up over time, which hopefully is not a shock to anybody here. And with that, we ran our algorithms and methods to produce the results that gave estimations of essentially the integration over the time period that we have from 1958 to 2020. As expected and glad to see, our lower bound is our lowest result. That gives us roughly 263,887 parts per million. And next we coming in second was the second lowest was the Simpsons method, and followed by a trapezoid method, and lastly our upper bound was our upper bound. And at least we were able to at first glance see, okay, these make sense as a result, and this made sure we were at least pretty confident in our results going from the methods that we created. And so based on this, our recommendation that we came across was Simpson's method in the end is going to be our most recommended option. It's fundamentally just going to be our most accurate approximation of CR2 emitted over the interval. It does the best job of handling if there is like change in increasing or decreasing iterating over the data. Whereas lower and upper bounds, they give you a good like estimation of like where the limits could be in the data, but it doesn't do a great job of handling behavior within the data and giving you that accurate estimation. Similarly with the trapezoid method, it does a great job of kind of like ballparking the median, kind of finding that middle ground, but it doesn't really give you that accurate approximation based on like the behavior of the data. And so that's why we would recommend the Simpsons method, whereas the other ones do a great job of helping you feel more confident about your use of the Simpsons method, but it won't be consistently as accurate as the Simpsons method. With that, it kind of gives you a good understanding to know how much CO2 has been emitted and feeling pretty confident about that. So hopefully that is just a good idea on how climate change is real. Thanks, guys.